Hi. Good afternoon. Our next presenter, Nick Coghlan, is that correct?
Coghlan.
Works at Red Hat on the PulpDist project. In his spare time, he's a C Python core developer, author of numerous Python enhancement proposals, and a regular presenter at PyCon Australia. Today, he'll be talking about path-dependent development.
Thank you. Yes, Red Hat Toolsmith, C Python core dev. This is basically based on a bunch of observations from about 10 years in the defense industry, working at Red Hat and working on a bunch of open source stuff. Many years ago, a statistician made a very useful observation. All models are wrong, some of them are useful. And earlier in the same book that quote comes from, he actually said, how wrong do they have to be to not be useful? And this applies to software as well. Software development, there's a classic trade-off. It basically says, you can have it fast, you can have it good, you can have it cheap, choose any two. That's actually not true. You can have all three, you just have to not be doing much. And so, to fit within that, basically we have to make all these decisions on what are we not going to do in order to ship something. And so, good enough to be useful, yep, ship it out the door. Of course, if it's just sitting on our servers and end users can't get at it, then it's definitely not useful to anybody. However, the decisions we make, particularly in early phases, to actually get stuff out the door, they're going to leave their fingerprints over the software long after those original decisions have been erased and new features have been added and so on. But you can't get rid of that history. And so what it means for something to be good enough depends on huge numbers of different things. It depends on what your priorities are, what your resources are. What are you building? Why are you building it? Who are you building it for? Who's doing the building? What tools do you have available to build stuff? And then one of the things is, how big a gamble are you prepared to take? And different industries, different tasks, it makes a huge difference. If you're building stuff for a corporate intranet, you can pretty much trust the network. There's not going to be too much hostile traffic on it. And you don't have to go searching for users because people are going to get told, you shall use this. But if you're building a web startup, internet is a hostile place. You can expect to be attacked. And your users are everything, because if users hate your stuff, they'll just go elsewhere. They've got heaps of choices, heaps of ways to spend their time. You want them to be using your stuff. And then you can go completely different, get away from the web entirely. And if you're selling hardware, you may be writing software to configure it. You may be writing software to manage it. And in that case, what you're really selling is the hardware. The software is just kind of a necessary evil to make your hardware useful. And so trade-offs are needed. We have to decide, what are we not going to do to get stuff out the door? And the obvious one, and this is kind of the core of iterative development, is you just do less. You make your initial version, you decide, we're going to do one or a few things really well, and everything else we're going to leave until later. And if you have a full set of requirements and you do 80% of 100% of those requirements, well, your software is useless because it doesn't do anything. Whereas if you pick 20% of those requirements and say, well, we're going to do those completely and make them work, your software can do something. It can't do everything, but it will be useful to a subset of your users. And one of the other big things is, if you add a piece of functionality badly, people who really want that feature will make it work for them, which means you can't take it away later, no matter how broken it is, because they won't remember that you took something away and gave them something better. They'll remember that you took something away from them. And so, yeah, doing less leaves more room to grow into the future. Flexibility. It's very, very tempting to avoid making decisions and say, oh, we'll just make it configurable, then we don't have to decide. Not usually a good idea. Everything you make configurable makes your testing harder, it makes your maintenance harder. Now, something people will sometimes say, oh, well, you don't need to make it configurable, so it's okay to hard code it everywhere. No. You do want to separate your concerns. You do want to say, well, yes, say, I'm only going to support SQLite in the initial version, but I'll still configure it in one place to say my database is SQLite. Everywhere else will get it from there. So later on, when you do decide to make it configurable, you only have to add the configuration support in one place. Everywhere else will inherit it. And then the other thing too is that there's a lot of flexible support tools out there that it can look like, oh, well, we don't need that flexibility. We can do it ourselves. There's some tools and some problems that are so well solved that building it from scratch just isn't a good idea. What you can do is you can use those flexible support tools like SQL Alchemy, and you just configure them the way you configure them one particular way initially, but you know that you've got that infrastructure there later on. When you do decide to make it flexible, you know your tools will support it. Other cases, there's bigger frameworks, particularly mega frameworks like Django. They lock in a bunch of decisions and make it hard to change them. But on the plus side, they block in a bunch of decisions. So you make one decision, I'm using Django, and a whole bunch of other decisions are made for you, and you don't need to worry about them. And because of that common core, you can get a very rich ecosystem around that you can work into. Another fun area of trade-off, and this is the cause of much evil in the world. There's an awful lot of software where you take shortcuts on the security front. It's really bad, but you can also understand why people do it, because it's like, hey, it's a trusted system, it's only going to run inside this thing here, and then somebody in marketing goes, hey, that's a really cool product, we should sell that to people. And you go, bugger. But yes, so the idea behind defense in depth is that even if you've got an insecure core, you can put a certain amount of perimeter defenses around it and make it semi-tolerable, but security is one of those very, very risky ones that if a system's ever going to be handed out to the general public or run on the public internet, it's very hard to reverse to engineer security back in if you've gone unsecure choices from the beginning. So it can be, that's a very tricky transition to make. Microsoft have actually, over the course of decades, mostly managed to do it with Windows, which is kind of impressive. But yeah, the basic idea is to try and make the easy option and the secure option the same. That can be a very challenging thing because you're trading off convenience against security a lot of the time. Another controversial one, reinventing wheels can actually be a good idea sometimes. And the reason it can be a good idea is that dependency management isn't always that easy, particularly if you're in an environment where you need to manage legal risk. And so if you're only dealing with a very small subset of a problem, it can be very tempting to just say, look, we'll just do something simple. And if you do it in a sensible way and you have a very limited modular API to that chunk of functionality, the basic idea is that you do the simple thing first that does what you need. As your needs grow, you don't make your custom solution more complicated. You get rid of it and you put a real solution in. And that's the number one thing to watch out for, is that if, say, you go, oh, well, I will do my own ORM, and, well, don't. But if you're doing a very simple subset of a problem, then okay, reinvent that wheel. Keep a really close eye on the complexity, because as the problem starts getting more complicated, as you start getting deeper into that problem space, there are usually going to be good, well-tested solutions out there that solve that problem thoroughly, and so you don't get attached to your reinvented wheels, because you will end up maintaining them for a very long time. You want to kill them at the first opportunity and replace them with something proper. Documentation is another lovely one. Open source tends to get hammered for poor documentation. Fortunately, the Python community tends to be better than most about encouraging good documentation. But it boils down to is how sophisticated are your users expected to be? If you're building something that's intended for software developers and only for the developers actually working on that product, then you can get away with some pretty piss-poor documentation because you can say, read the source. But if you want to build your product that can be deployed or used by non-technical end users, then either your UI has to be so good that people don't need documentation, or it needs to be thoroughly documented to explain everything that's needed. This can be particularly obvious in domain-specific software, which is designed to solve problems in a very specific technical domain. One of the challenges in that space can be how much you're trying to teach users about the domain and how much do you assume they already know. Because if you're writing biology software and it's designed to be used by experienced biologists, then you can assume a heck of a lot and just use terms and expect people to know what they mean and not worry about the fact that a non-biologist is going to have no idea what it means. One of the other things is that if a piece of software is in a high state of flux, then documenting it may end up being net loss because you've just increased the amount of work you have to do as you iterate through changes. So if something's highly unstable, then it may be better off waiting until it stabilizes a bit before you lock the documentation down. The risk you have to trade off here is that sometimes documentation is a wonderful way to highlight when you have a design problem, or particularly an API design problem. One that happened recently in the standard library is we brought in the IP-ADDR project as IP address in the standard library. IP-ADDR was written for networking experts. It assumed that people already knew all the networking terminology, that they already knew how networking and IP addressing worked, and it didn't follow the standard terminology. It kind of cut a bunch of corners that if you already knew how networking worked, you'd be able to use that API. If you were trying to use that API to learn how networking worked, you had no chance. And so most of the differences between the standard library version and the upstream version are all around that beginner audience of using the module to teach people how the domain works. And so it's, again, a tricky trade-off where you have to decide who's your audience, how much documentation do they need, and write what's needed for the audience that you have. Another interesting space is, and there's entire conferences devoted to a bunch of these, test quality is one where a lot of people say, oh, only one assert per test. Never do more than one assert in a single test. And that's actually really good advice, because a fine-grained test means that if something breaks, that it will point you directly to what you need to fix. The problem with that is fine-grained tests can be a pain to write, particularly if you're doing integration tests, where you need to spin up a bunch of infrastructure and then tear it down again when you're done. They can be slow, they can be hard to write, can be problematic. So coarse-grained tests are wonderful, because you set it up, you do a bunch of things, you make sure that everything you expect to happen happens. And the thing is, if it never breaks, a coarse-grained test can be just as good as a fine-grained test. And so one useful trick to do is you actually write your coarse-grained tests first, and if they continue to pass, then cool, you've made sure that it keeps working at least as well as it did at the start. If it ever fails, then you can add your fine-grained tests to actually narrow down the failure, and if that failure ever happens again, then it'll get picked up straight away. And so it's kind of like you ain't going to need it applied to your test suite, because the fine-grained tests, if they don't fail, that debugging aid's not actually going to help you much. Sometimes you'll hear the claim made that slow tests are useless. If your tests are too slow, you may as well not have them. That's rubbish. Slow tests are way better than no tests, because at least even if slow tests aren't run, even if they're too slow for your developers to run them before every commit, you can at least run them selectively to cover what you're working on, and you can hook them into a continuous integration system, so you at least get some kind of alert when when you've broken something. The other one is that you'll often hear people say, look, your test shouldn't need any manual setup. You should be able to just run them. And again, excellent advice. You're not going to get there on day one. And so tests that require, you may have to, say, set up a database manually or set up a web service and say, right, test against that. And again, a heck of a lot better than not having the tests at all. A little bit of manual setup, you can put up with that for quite a while. And then one of the other common pieces of advice in test quality is that particularly if you're doing test-driven development, not to commit a fix if you haven't figured out how to test it to make sure that net problem never comes back. That's wonderful. Doesn't really work if you've got bugs that are hard to reproduce in development. If you can't reproduce it effectively, you may be able to figure out what the problem is through analysis and looking through logs and that kind of stuff, and figure out how to fix it. And in that case, just fix it. Often it can be useful to put a comment in saying, hey, this is here to fix this particular problem. We couldn't figure out how to test it. One of the many good uses for comments. Another one which is, again, something that is a development process that can be a useful trade-off, is that code is written to tell computers what to do, and it's written to tell people in the future trying to maintain your stuff what it's meant to do. Tests will cover the fact of, are you telling the computer the right thing? What code reviews will tell you is, are you telling future maintainers the right thing? And the interesting thing is, if you've got a very small development team and they're spending lots of time together and are all across the whole code base, then reviews may not help you much. You'll get a fair bit of coverage just from working on shared code. Where they really come into their own is as the team grows. They're an amazing tool for senior developers to mentor junior ones, maintaining code consistency, maintaining some level of awareness and ownership across the whole code base rather than people getting siloed into particular bits. If you don't have the right tools, the overhead's going to be awful. So you really do need the tools to support this kind of review process. And there's lots out there like Reinfeld and Garrett and Review Board. And so there's heaps of ways you can do the code reviews, but as a team grows, they definitely start becoming necessary. This is really only just scratching the surface of all the possible trade-offs. Performance and scalability. If you're building your system to handle thousands of users and it's going to get deployed onto a corporate intranet for a company of 100, probably over-engineering something somewhere. Reliability, not everything's mission critical. Usability, not everything lives or dies by the happiness of its users. And this is why enterprise software is almost universally awful, because the people buying it are not the people using it. Maintainability, if you're doing a throwaway script, hope that it really is throwaway. But business risk, different organizations and different context, it'll change how much you're worried about legal implications and that kind of thing. Process automation, if a process is still heavily in flux, so like if you're doing a process and every time you go to do it, you're tweaking your scripts that automate that process, it's a sign that that process isn't stable enough to be automated yet. And yeah, there's more. It's one of the most interesting aspects of software development is how do you make these trade-offs. And so these decisions are inevitable, and we kind of want to do them in a way that doesn't come back to haunt us too badly later on. And so one of the main things is to have an exit strategy. By trying to become aware of all these different trade-offs that we all make every day as we're developing software, if we have some idea of what we're not doing and we're making a conscious choice to not do it, at least not do it now, then it makes it easier to have in mind some way of how we're going to get out of it later. And this is where you ain't going to need it. It's kind of more like, well, you're probably not going to need it, but if you do need it, here's how to get yourself out from where you are. And then the idea of iterative development then is you kind of have this huge cloud of these are the things we might do, and these are the options we're keeping open. And then the actual fixes that you do will depend on the demands that come from the business and from your users and what you actually decide to do later on. And one of the other things too is that some of these decisions that you make really will lock out certain possibilities in the future. And if you know that you've said, look, we're just never going to support that use case properly, and someone comes along later and says, hey, look, I want to do this. And you can just go, well, look, no, it's flat out a bad choice for that because of these reasons. And so, yeah, sometimes the only right answer is no. Patterns and processes. A lot of the stuff that you can see about software architecture and design patterns and software processes and methodologies, it's all about managing this. It's about keeping your options open without making your current software more complicated than it needs to be. If a system doesn't have a test suite, that's kind of where you have to start, because being able to run tests is what lets you change stuff without breaking anything that your users are relying on. One of the other two things is that people often don't realize just how different prototyping is from implementation. And the big difference between the two is that when you're prototyping, the trade-offs you make are very, very different, because fast and cheap are the order of the day. Whereas once you get into implementation, you need that good. It needs to be good. You're willing to pay more. You're willing to take a bit more time. Or you go into the full incremental development mode, and you just do small increments, which are all fast and good and cheap. But yeah, the big thing is that when you're prototyping, you're exploring, you're trying to figure out what you can do. When you're implementing, you know what you want, you just have to make it happen. And there are social implications to this too, which is that design decisions now design decisions that were made years ago may look really bad now, but back then they may have made perfect sense. And one of my favorite examples of this is the URLib2 API. Came from an era when HTTP hadn't won yet. So HTTP now is practically a transport layer in its own right. And that's what the request module does. It just says it's HTTP all the time. Whereas URLlib, HTTP was just one protocol among many, which is why it's a pain to use for HTTP, because you have to tweak it and tailor it and say, I'm using HTTP. So I think as software developers, we actually are getting better at building software. But our ambitions for what we try and do with software are more than keeping pace with our abilities. So anyway, so people may have seen the promise in the thing of, in the subtitle of the fact that I'm currently using SQL Alchemy as part of a JSON validator. And so, yeah, this is the story of how that came to happen. Innocent enough start. It's a mirroring network that basically manages a bunch of rsync jobs. And the original job definitions are really simple. Guts of it were, here's the server, here's the directory, sync it down to here. And I wrote a custom validator for that because it was really easy. Turned out that simple format was too simple because you'd have multiple jobs coming from one server and you'd want to put them in the same place on the local drive, and there was an awful lot of duplication between the configuration files where lots of path fragments were in common. And so what I did was I redesigned the user format, the file format, to basically reference out so that you'd say, right, I'm making this tree, it's part of this local site, which will define a bunch of stuff about the local directories, and I'm copying it from this remote site, which will define all the remote details. And this kind of meant that the simple validator just couldn't handle the job anymore. There was too much extra stuff it needed to do. So I could have upgraded the validator, but this is the thing I was talking about, that you've got to keep an eye on your complexity. And this tripped mine. I just said, no, this is too far, step too far, I need to change it. Could have gone for an external JSON validation library. Problem was, I had no idea what's a good validation library. I would have had to be starting research from scratch. Or I could go a relational database, because the constraints I needed to enforce were pretty similar to what a database does. Now, there was another factor that I had another problem that I needed to solve at this point, which was, for the UI, I needed to be able to filter by the IDs, and I needed to sort by a bunch of different fields in the config file. So this was sounding very familiar. And sure enough, relational database. It's like the problem I had was the problem relational databases try to solve. Writing SQL by hand is still painful, and SQL Alchemy was already in the environment I was deploying to. So that was basically my solution, was I'd read the config file in, run it through the basic validator, and then throw it at the database. If it stuck, cool. Still some very rough edges. SQLite gives you awful error messages if you violate a key constraint. It's just ugly. And the other problem is that currently changing the schema is very clumsy and difficult. There's about 3 places or more that you have to change to add a new field. So where it will go in the future, the database may become the master, at which point this will just be an export format. I may just try and fix the error messages of the current system, or I may throw it all out and put a real schema validator in there. And exactly which will happen, that depends. So thank you very much.
Thanks very much. Any questions? Any questions? No? I think we might be right. You obviously, all the information was there. No questions. You answered all of them. Cool. So thanks very much. We've got some a mug and some coffee for you. Sorry.
Thank you.
Cheers. And yeah, we'll be back in about 10 minutes.